topic, which is testing, and after this we'll talk about debugging in Android. So what exactly is testing in Android, and how do you go about carrying out testing? See, many of you are starting to think about your course projects. If you have sent me the proposals, I have read almost everybody's proposal now. If there was a comment that I needed to send back to you, I would have sent you an email reply. If not, then assume that I don't have anything specific to tell you. For those that I had something to comment upon, I sent back a reply to them. For your case, I think I have discussed with you, so nothing much left. And I appreciate the way you're combining Unity 3D with the standard iOS. Do you have Unity 3D, or you're just using only the open license part of it?
I use the trial version.
Trial version.
And then I find the cracked version of private beta. But you're going to try with that, right? So you're going to try one part with. Kind of interesting to see how it evolves, because I have seen we have worked with Unity 3D, but we did game. One FIP group 2 years ago did a game, but that was directly exported into iOS device, completely implemented in Unity 3D. We didn't have this additional iOS thing involved, but I saw the blog posting that this guy wrote about how he combined the two. It was quite interesting to read about it. Okay. So, getting back to testing, so for the rest of you who are not here, if you want to discuss your projects with me, feel free to come by my office, and I'll be happy to talk to you. I have looked at almost everybody's proposal, and where I have feedback, I have sent back emails to them, and to some people I have directly talked. During like you and some of the other groups that are not here, I have talked to them directly. I think that will be the best way to get feedback from me also. It will be appropriate for you to just come in and talk. I will be around for the next 2 weeks anyway, before your projects are due. So getting back to testing in Android. So as you realize, when you implement any application, one of the important parts that you need to implement is how you carry out testing of your application. How do you make sure that what you have implemented is correct or not? If you have taken courses in software engineering, if you have taken the course in software engineering, you would have been taught about the standard methods for carrying out tests, including all the different kinds of testing: black box testing, white box testing, regression testing, and other kinds of test cases that you have been taught about for general software. All those approaches are still applicable even with Android. So you can just simply borrow every one of them and then carry out those tests even with any Android application. But in specific, when you start out doing an Android application, this set of rules applies in general, not just for Android, but some of the measures that you can take in order to improve the development process of your application itself. First and foremost, you should always start out by writing down some coding standards and guidelines, especially if you are doing as a group. It's always a good idea to write down some coding standards and guidelines. That is, every group knows how to structure the code, how they are supposed to define the variables, how they are supposed to define the call signatures of all the methods, and so on. and document each and every part of the code. Indeed, when you turn in your project, that is one of the things that I will look for in there. How much is your code documented such that a lay person, like for example, when I read code that is submitted by all of you, obviously I have no idea what you have implemented unless you document it in the code there. So that's one thing that I will look for in judging how well you have implemented your application. So coding standards and guidelines are very important in order to ensure that things are implemented correctly. The second part is, of course, make use of some kind of versioning system. Different people have different preferred versioning systems. CVS, for example, SVN, Git, whatever that you feel is the appropriate versioning system that you're familiar with and that you can use. It's always a good idea to make use of them, so that when it comes to the demo day, you don't walk into my office and say, all my code disappeared last night while I was doing my testing, and then somehow I'm not able to recover any of the code. Do versioning so that if at all you end up damaging the code that is on your computer, you will be able to retrieve at least a previous version from a saved version build. Either use CVS, SV, or any one of them, Git, whatever that you feel is appropriate. So 2 parts. The third one is defect tracking system. Of course, since your projects are fairly small, you can simply do simple notations for defects and so on. But in general, if you're implementing a complicated application, especially if you're doing a production level application, it's always a good idea to build a defect tracking system. What is the purpose of the defect tracking system? Whenever people encounter bugs, whenever people encounter problems with your application, they should be able to submit a defect report to you. Maybe you yourself encounter defects while you're testing your application. You should be able to log the defects. And then not just log the defects. When you find a way of fixing the problem, you should also be able to describe how you resolved the problem. And all this should be documented in such a way that subsequently, anytime you go back, you will be able to refer to this information and realize whether and how you managed to overcome the problem that you encountered. Furthermore, a defect tracking system is very, very useful if you are conducting regression testing. As we realize, whenever you do different versions of your application, when you transition from one version to the next version, it is always a good idea to carry out regression testing. If you remember from software engineering, regression testing means that you carry out testing using all the problems that you encountered earlier, just to ensure that those bugs are not repeated in the newer version of the code, and so on. What this all means is that you need to have a systematic testing plan, and you need to carry out systematic testing of your application such that you have figured out and made sure that everything works correctly. And this starts out by designing very good test plans, a set of tests that carry out a whole bunch of tests on different aspects of your system. Fortunately, Android comes with its own support for testing. We will go through some of the features that the Android testing framework provides for you for testing out the different parts of your Android application. Furthermore, you can take advantage of the JUnit testing that you're familiar with in Java for also for carrying out tests. So let's look at each one of these in more details. First, coding standards. Coding standards. So that was the first step that I mentioned. You need to have a common way of handling exceptions and errors. Obviously, within your code, you would always encounter situations where you might end up with exceptions being caused or errors being caused. In Java, for example, you have the try and if fails and so on, various methods where you catch exceptions and then deal with them and so on. So you need to devise a common way of handling exceptions and errors, logging exceptions and errors and so on. Second point to note about Android is that if you have any process-intensive operations, the most important thing to do is move the process-intensive operations off the main thread. What is the problem if you do that on the main UI thread? If you do any operation that takes a lot of time on the main UI thread, the main UI thread will block. If it doesn't respond within a period of time, the Android framework will come and kill your application, or issue the ANR, the application not responding message to you. That's something that you have to keep in mind. Third problem that you should, from the beginning, try to do is to do appropriate memory management, including to reduce the amount of memory being consumed by your application. When you create objects and resources that you're using within your application, as soon as you have completed using them, release them so that the memory can be reclaimed back by the system. So release the objects and resources if you don't need them anymore. Don't keep things around. Don't keep objects around unnecessary to reduce the amount of memory being consumed. Okay, and you need appropriate memory management techniques. We have dealt with this in more detail in the earlier chapter about memory management, how you track memory allocations using the allocation tracker and so on. And then specifically track down memory leaks and then avoid problems due to memory leaks. That's one thing that you should definitely make use of. And one more thing that you should definitely adopt in Android is to make use of resources. Remember that there is this RES directory under which you put all the things that you declare as resources. As far as possible, don't hard code data into the code or into the layout files. Data in the form of, like, for example, if you're using strings in your code and so on, better put them into the strings.xml file rather than directly putting them into the layout files, or even worse, directly using it in the code within your application. Try and make use of the resources to offload all of these things from the code as far as possible. Use the resources directory to keep all these things. This enables updates to be done a lot more effectively in a centralized manner, because if you need to make changes to any, for example, a string that you're using in your application, there will be one place to go and make the change, instead of every single place within the code where you have made use of that by hard coding the information. Try to avoid hard coding information into your code as much as possible. Now, as I mentioned earlier, in software engineering, you are taught about the generic testing methodologies. Obviously, this is not the course to review all those things, but I'm sure if you have taken a software engineering course, you have been taught about the different testing methods. Specifically with respect to Android, what are some additional testing strategies that we can make use of for Android itself? First, integration testing. Obviously, within Android, your application obviously runs on a real device. So the ultimate proof of the pudding is in putting it down onto the real device and integrating with the core device, and then testing to ensure that the software works correctly on the real device. Okay? And your application should suspend and resume appropriately, and your application should gracefully handle interrupts coming in from the operating system. Interrupts in the form of, for example, while your application is running, you might have incoming messages popping up, incoming calls popping up, user may power off the device. How do you handle all these things? Especially when you're downloading something within your application and the user decides to power off the device. You should be able to respond to these kind of situations very appropriately. Okay? So this is integration testing that you should obviously carry out. Upgrade testing. When you design your Android application, obviously you make certain assumption about the minimum SDK level to which you are designing your application. So you would specify that in your manifest file, saying minimum SDK is 8 or 9, depending upon whether you're going to support Android 2.2, 2.3.3, or 2.4, or whether you intend your application only for Android 4.0 plus devices and so on. But every time there is an upgrade either in the device or in the operating system, as you see, periodically, even for devices that are already in the field, there will be periodic updates issued for the base Android OS in there. So updates that the user does to their devices should not break your application. It is always a good idea to test your application, assuming that such upgrades will be done by users, which means that test your application for all possible configurations of Android's different versions that you're going to, different versions of the SDK that you're going to support. Furthermore, every time there is a new SDK version released, always retest your application on the new SDK. Sometimes we do notice that an application that worked very well in one of the earlier SDKs suddenly starts misbehaving in one of the later SDKs. We have practical experience doing that, right? So it's always a good idea that if you are going to keep your application valid, it's always a good idea to do testing every time you have an upgrade in your device. If you're going to support multilingual, multi-language, and also depending on the location of the device, different locales support and different languages, you should always carry out the internationalization testing. We have devised applications where we support multi-languages. We have devised applications where we support 3 different languages, and we had to carry out specific tests to ensure that the correct set of resources are used in each of the language selections. So, for example, we had a case where we had the language supporting English, traditional Chinese, and simplified Chinese, and we had to automatically shift all the resources that are used, all the string resources and other resources that are used within the application to match the language that the user prefers for the user interface. So automatically changing the resources being used. So internationalization testing, very important, because obviously you're going to have your app being deployed by people in different locations with different settings, with different language supports on their devices. Obviously, the ultimate testing is usability testing. When you design an application, it's always a good idea to carry out usability tests. Let users make use of your application and then give you feedback on whether your application is and its user interface is devised properly or not. Power consumption, yet another important aspect to keep in mind. All these have to be tested as you go along within your system. Performance testing. Performance testing in terms of how much of resources your application is using, memory usage of your application, whether there are any memory leaks or bottlenecks within your application. Like, for example, if you're doing long downloads in the background, you should still keep the UI working properly so that if the user, for example, decides to cancel the download, you should be able to quickly recover and come back. If the user initiates the download, let it take place in the background while you still provide interactivity to the user at the user interface. And also in general, things like, for example, carrying out tests on how much resources your application is consuming, how much memory your application is using. Is it using excessive amount of memory? Is it using excessive amount of power on the device? If your application is draining the battery too much because it is requesting frequent location updates, or if it is accessing data services too frequently and then consuming the user's data allocation. All these things have to be tested. Conformance testing. If there are policies and licensing issues that need to be dealt with, always make sure that you are meeting these requirements. Make sure that you are not violating any of these policies and so on. Edge case testing, another important aspect. When you devise your applications, if you are the only person who is testing the application, you would be biased towards testing the application in certain ways. You don't know what the consumer in the field might end up doing to your application. So it's always a good idea to give your application to people that don't know anything about how your application works and observe how they make use of it. People will touch all the different parts of the of your user interface in random ways and so on. And obviously in ways that you didn't intend them to do, but your application should still be robust enough to withstand all that. Android has a mechanism where you can actually carry out such random testing without using a human user. I'll talk about that in a short while, called Monkey Runner and so on. We'll talk about that. Primarily devoted to testing user interface related things. Another important feature, screen orientation change testing. We do see that users rotate their devices, whether intentionally or unintentionally. People rotate their devices. If you intend your application to adapt to screen changes, you should definitely test to make sure that the layout changes in the layout when the screen orientation changes is appropriately handled. And furthermore, things like, for example, when you're using resources in one particular version, like as I explained last time, the issue of memory leaks that might occur when you load resources within your activity and then don't release them before you deal with screen orientation changes and so on. Configuration changes testing. For example, device configuration changes. For example, if you assume the availability of keyboard for the sake of making your application run, then you might, if a user installs it on a device that doesn't have a physical keyboard, then you're in trouble. Like, for example, making use of the D-pad keys that we did in a couple of applications. We assume, like the ball game example that I gave you, we were using the D-pad keys in order to move the paddle around. Obviously, many phones don't have those D-pad keys anymore. So if you implement an application assuming that those keys are present and it doesn't exist in certain devices, obviously your application has no way of working on those devices and so on. Okay? And furthermore, even changes to device configurations and language, system language and so on should not break your application. Always good idea to make sure to test out all these features. External resource dependence testing. Your application may expect certain resources to be available. Like, for example, if you design your application to make use of the camera on the device, and then a user installs it on a mobile phone that doesn't have a camera and tries to use your application, what are you going to do? If your application simply just keeps doing force close right when the user starts the application, then the user will think that there is something wrong with the application and then simply give you bad rating. On the other hand, if you give a nice message to the user saying, look, this application is not designed to run on your device because your device does not have a camera, then at least the user knows that it is not the application designer's fault, it is the user's own mistake in installing this application on his device which doesn't have a camera. Similarly, if you are assuming that a separate barcode reader is attached to your device, and obviously most users don't attach barcode readers to their device, if you make that assumption and implement your application, obviously it won't work in many cases. Okay? Even simpler things like, for example, availability of network access. If your application is dependent on availability of network access, then it is possible that the users may turn off network access on their devices, right? Very often, when I am not in a location where I have Wi-Fi, I usually turn off Wi-Fi in order to save the battery. Well, most often I keep the Wi-Fi off in order to save the battery, because if you turn on Wi-Fi on your device, it tends to drain the battery a lot more faster than having Wi-Fi off. Similarly, if I have GPS support on my device, I keep it off most of the time, because GPS support, if I keep it on, it will keep draining my battery. Similarly, if I have 3G services available on my device through my subscription, 3G services, obviously they're going to charge for all the data that I upload or download. So in order to avoid unnecessarily uploading and downloading data without my knowledge, I will turn off 3G or GPRS access on my device. But when I invoke the application, I may not turn on this connectivity when I invoke the application. If your application depends on the connectivity, then obviously when the user tries to start the application, it won't work. In the worst case, it will force close and the user will be annoyed. It is better for you to explicitly check for the connectivity from within your application as your application is started, to ensure that the user has this connectivity turned on. Even important that as your application is running, the user may decide to turn off this connectivity, and you should still be able to make your application gracefully recover from these problems, not simply force close. So always keep checking to make sure that you have access, network access, if you need it within your application. Similarly, for SMS, Bluetooth connectivity, and so on. Graceful handling of changes in the availability of external resources is very, very important. Abrupt handling, or even worse, just letting the application force close, is not a good way of handling these things. So always put in checks to ensure that you check for the availability of these resources before allowing the user to proceed. If they are not available, at least warn the user saying, you don't have these things on, so I won't be able to, much of the functionality of the application may not be able to be provided for you, and so on. So that way you inform at least the users, and the user's expectation is appropriately modified because they don't have access to these resources. Okay, having said all that, how do you carry out testing within Android devices? Now, in Android, the key features of how the testing framework in Android is provided for you. Again, Android has many testing features built into the framework itself that enables you to carry out a lot of interesting tests on the Android device. We will go through several of them one by one as we go along in this course. Now, first, the Android test suites that you can design are again based around JUnit testing. If you have taken a Java course and you have been taught about JUnit testing, then you know how to make use of it. JUnit testing is nothing but unit testing. Unit testing is where you carry out testing of specific aspects of your classes and so on. If you are using a class within your Android application, and this class does not make use of any Android API calls, since Android is based on Java, you can default to using standard Java JUnit test cases to test out all those classes that are independent of the Android API itself. Obviously, there may be many classes that you implement within your application that do not really call any of the Android's API functionalities. Okay? In that case, you can simply design those test cases as simple JUnit test cases. Okay? But if certain classes are making use of Android API, then Android itself provides JUnit extensions in order to carry out testing on Android's components including activities, services, receivers, broadcast receivers. What is the fourth one? Content providers. Each one of them. So Android's JUnit testing extensions, which I will go into a little bit detail, will look at how this is provided. So these extensions provide component-specific test case classes. So using these test case classes, you can test different aspects of each of the component, including testing the lifecycle methods of each of these components and so on. So these classes provide helper methods, including for creating mock objects and methods, so that you can control the lifecycle of a component. Recall that the lifecycle of any component is controlled by the Android framework. So if you have to carry out testing, you want to be able to create those conditions where those lifecycle methods are invoked within your testing framework. That is enabled for you by the Android's JUnit extensions, which we will talk about in more detail. Similarly, for example, if you have designed an activity that accesses a content provider, if you need to carry out a testing on that activity, the activity requires access to a content provider, and if you don't want to provide the real content provider for testing, instead you can supply it as a mock object, mock content provider, which supplies mock data for your application to carry out tests. Similarly, if you need GPS information to be delivered to your application, you can deliver mock GPS information to your application. We saw examples of how we can use that in Eclipse with built-in emulator control in order to deliver mock GPS information to the device and so on. So these Android's JUnit test cases. All these test suites in Android, set of test suites in Android, they are all contained in what are called as test packages. Now these test packages have the same structure as the standard Android application packages. So you would notice that the test cases are all configured and implemented just like the way you implement a standard Android application. I will show you an example in a short while. And so you don't need to learn a new set of tools or techniques for this purpose, for designing and building the tests. You're already familiar with it. The test case implementation is very similar to the way you implement the Android's standard components. Okay? And this test case invocation and carrying out the tests are all part of Eclipse IDE. I will illustrate that with an example in a short while. Okay? Besides these, Android also has two different additional tools that allow you to carry out tests. We have something called the Monkey Runner, which is for carrying out API testing by writing Python programs. So you can write simple Python programs to carry out testing of the APIs in your device. We'll go into a little bit of detail on the Monkey Runner. I'll show you some examples in a short while. If you need to test out your user interface, there is another tool called UI App Exerciser Monkey. What's the purpose of this tool? It acts like a monkey. What does a monkey do? You give a monkey a device. What's the monkey going to do? It's going to do everything that randomly on the device. Monkeys and children are very good ways of testing your application. Give your application to a little child and see what it does. Okay? Similarly, you can give your application to a monkey and see what it does with your user interface. In other words, you can't get hold of a real monkey, so you make use of this particular tool called as Exerciser Monkey. And the job of this UI App Exerciser Monkey is to randomly create user interface events on your device, randomly create events like touching on different widgets on your screen and so on. So that is one more way that you can carry out extensive testing on your Android device, on your Android application. Let's go into a bit more details of each of them to see how this is carried out in practice. Now this whole setup for Android is captured in this particular picture here. This is your application, and then for your application, Android provides something called the instrumentation test runner, to which you supply a test package, and from the test package you issue calls through the instrumentation test runner to the Android to your application package. The instrumentation test runner also supports test tools and monkey runner, which we'll briefly review later on in this chapter. And for the test package building itself, what does the test package do? It captures all the set of tests that you want to carry out on your application. So it captures the test case classes, including instrumentation test cases, which I'll talk about in more detail, JUnit test cases. If your application requires objects to be supplied, you can supply mock objects from outside for your application package. All this is supported through the Android test package support that is provided for you. Let's look at each one in more detail. First, we will look at JUnit testing. If you have carried out testing, if you have taken courses in Java, you might have been taught about JUnit testing. If not, let me briefly mention to you about JUnit testing. Again, this is not a comprehensive coverage of JUnit testing. Some simple methods of carrying out JUnit testing. Now, what is a JUnit test? Obviously, as the name implies, it allows you to carry out unit tests. If you have taken software engineering before, you would have been mentioned about unit testing and so on. So this is what is supported by JUnit test in Java. So this JUnit test is a method whose statements test part of the application under test. And then you will organize your test methods into classes, which are called as test cases or test suites. What do these test suites do? They issue a bunch of calls into your Android application in order to test the various aspects of your application. So every test is an isolated test of an individual module in your application. Okay? And so every class is a container for the related test message. Although you're also provided with some helper methods, especially when you make use of Android's built-in additional tests, as we will see in more detail. For JUnit testing, you're basically going to build one or more test source files into a class file, and then carry out the test cases. I will show you with an example in case of Android in a short while. So for JUnit, you use something called test runner to execute the test classes. So within Android, you basically make use of the test tools to load the test package and the application in the test and the tools to execute the Android specific test runner. Okay? And in addition, you can use JUnit's assert class in order to display test results. What does the assert class do? The assert methods that are provided for JUnit enable you to compare the values you expect from a test to the actual results obtained from running the application. And then if the comparison fails, then the assert method will print out an exception or print out a message on the screen, on the console, and so on. Okay. Now, Android also provides a class of assertions that allow you to carry out different types of comparisons and for testing the UI and so on. Now, before we proceed, let me also show you with an example first by running the test case to show you how you carry out the test case, and then after that we will go into the details to see how this test case works in practice. Now, this particular example is based around the Hello World example that you have seen earlier. So in this case, I have implemented the Hello World example here. What does this Hello World example do? It simply prints Hello World onto the screen. That's what you would expect, right? To carry out a test of these, we create a separate class, or this could be easily included into the original application itself. So you can, here I have created it as a separate test case here, and in here I have the test code here. How do you carry out the test? You select the test case, and then in run, you say run as Android JUnit test, and then this will result in the test being carried out. And then at the completion of the tests, it will print out messages on the screen like this. com.example hello Android tests. It tests two different things and then prints out the information. Now I will go into the actual code to show you how this test case works in practice. But before that, I need to show you some more details about how Android provides certain instrumentation cases in order to carry out tests of different lifecycle components of your Android components. Lifecycle methods of your Android components. So what does instrumentation in Android provide? This provides control methods or hooks into the Android system. And this enables you to control an Android component independent of its normal life cycle. When you start any Android component, like an activity and so on, depending on what happens with that activity, it passes through this whole bunch of life cycle methods, right? When you start, you have the onCreate method being invoked, and subsequently after the onCreate, onStart, then you go on to onPause, onResume, and then you land your application. Similarly, when the activity is being shut down, then you go through the pause, on stop, and on destroy cycles, and on destroy lifecycle methods, and so on. Now, with using these instrumentation cases, you can control how Android loads application, and this is what enables you to test code by specifically invoking the different lifecycle callback methods directly to test how each one of those lifecycle methods of the component work correctly. Okay, and so also you could make use of this to run some components of the application in a separate process if required, and so on. And you can invoke the callback methods. Remember, there are several callback methods that you create when you run, when you devise various Android features. And so you can specifically invoke the callback methods in your test code to ensure whether the callbacks are being handled correctly or not in this particular case. So what I will do is I will go through some of these and then show you the code also to explain how this works in practice. Now, these instrumentation features allow you to load both the test package and the application into the same process in order to carry out the tests. Okay, this method, that is both the test package and the application and the test being in the same process, allows or enables the tests to invoke the lifecycle methods of the component, and also enables it to examine the different fields within the components in particular case. So, how is this provided in Android? This is all supported by using the various test case classes, several test case classes. So you basically, for implementing a test case, you will extend one of these test case classes in order to carry out the different tests. So in Android, we have several test case classes that extend the test case and assert classes of Java. Java already has this test case and assert classes that are available for JUnit testing and so on. These are extended in Android by using something called Android test case. So the Android test case is an extension of the test case, and it provides for the JUnit standard things like setup and tear down methods and JUnit's assert methods. So using the assert methods, you can assert to see whether certain conditions are being satisfied or not in particular components. These methods can be used for testing permissions, guard against memory leaks, and so on. And also provides component-specific test cases, for example, for activities, content providers, services, and so on. And this is all done by using application test case. This is for application object setup and teardown, if you want to test out how an application works. There is another one called instrumentation test case. The instrumentation test case is used for instrumentation methods, usage in test cases, and so on. And you have additional test assert classes that are available for power assertions and so on, which we'll not go into detail in this particular course, but they are available for you in practice. In addition, as I told you, we have this mock object classes. What this allows you to do is to supply the system with mock system objects, like mock contexts, mock content providers, mock intent objects, and so on, in order to carry out tests. So, for example, if an activity is going to be invoked from an implicit intent from somewhere, you can test that out by issuing a mock intent to see whether the activity is being properly invoked or not, and so on. Let's look at one by one. For activity testing, now, when you look at an activity, you realize that an activity has certain lifecycle methods that we have just mentioned: on create, on start, on resume, on pause, and so on. So these are all lifecycle based callback methods. Now, when are these methods invoked? These methods are invoked by the framework depending on the current lifecycle state of your application. Now, the instrumentation framework that is available in Android will enable you to call these methods directly. Now, obviously, these methods are invoked by the Android framework. You are never calling these methods directly yourself, right? You implement those, you are expected to implement those methods, and then that's your job when you design the application. You simply implement all these methods and then put the code into each one of these methods appropriately to design the functionality of your application. But you never ask yourself the question, when are these going to be invoked? Because that is under the control of the Android framework itself. The framework will invoke these methods depending on the current state of your activity, okay, current lifecycle state of your activity. So, if you need to carry out to see, did I implement the onCreate method correctly? Is the onCreate method doing the right set of changes or not? You should have a method of directly invoking that onCreate lifecycle method. Those are enabled by the instrumentation framework. So the instrumentation also enables you to send UI events from a program to an application. All these enables you to carry out several different test cases. So the activity test case, activity testing API, is based around this base class called as instrumentation test case. What does the instrumentation test case provide? It provides these methods, lifecycle control methods. So for example, you can start the activity under test, pause the activity, destroy it by using the methods provided in the test case. So you could say, start this activity, and that will result in the onCreate method being invoked of that activity. You can pause the activity. You can, from the instrumentation class, you can issue a command to pause the activity, and so on. Okay, and also instrumentation test case allows you to inject dependency. So, for example, if your activity is depending on mock objects being supplied by it is dependent on system objects like contexts or applications or content providers, content that is provided from elsewhere. You can supply these as mock system objects to your application, to your activity, and then carry out the activity, and so on. So this way, you can carry out the testing of the activity independent of the real content being supplied. The mock objects are obviously supplied only to carry out the test cases. And also user interface events being invoked by your application. Okay? So, again, within Android, you have the standard JUnit framework also that is available by extending the test case and assert. Within Android for activity testing, you have these two test cases called Activity Instrumentation Test Case 2, which I will show you how to make use of it in order to carry out the test cases. You have Activity Unit Test Case, which is like the JUnit test case. For other standard launches, you can also use something called Single Launch Activity Test Case and so on. Let's look specifically at Activity Instrumentation Test Case 2 class and see how you make use of it in practice. Now, as I mentioned to you earlier, we have this simple example that I'm going to use to illustrate how the test cases are made use of. You are all familiar with this Hello World or Hello Android application. We have implemented this as one of the first applications in the lab, right? This allows you to so let me see where my this is my this is my emulator. So what does this Hello Android do? Obviously, Hello Android is going to simply run on the device and display Hello Android on the screen. That's the simple application that you have there. Now, I want to be able to test this application. And to test this application, I have written this simple test case here. I'll first run the test case as I showed you earlier, and then we'll go back and see how exactly is this test case implemented in practice. So I can carry out this as an Android JUnit test, and then it would run the test, and then it'll inform me of all the possible conditions that occur here. Two conditions are being tested: testing preconditions and testing text. How exactly is this implemented? To check how the test case is implemented, I open this package called Hello Android Test.java. Let's look at the structure of this. This particular example is provided also as part of the Android's standard tutorials, so you can look up this information even there. So what am I doing here? I have declared this as Hello Android.test, and then I am importing this particular class. This is nothing but the Hello Android application that I just implemented earlier. Okay. So what do? I declare a new class by extending this Android Activity Instrumentation Test Case 2, and you specify this argument to it called Hello Android to specify that you are carrying out the test on the Hello Android activity here. So, so you declare this activity, and then you get a reference to this Hello Android activity. By declaring that, you have a text view and so on. So what you do here is that once you declare this test case, this is the constructor method of the test case. So here you are saying com.example.hello Android, and then you supply the Hello Android class essentially specify to the system saying that is the class that I want to carry out the test on. That is the activity that I want to carry out the test on. After that, you do an initial setup. Setup is one of the methods that is supported by this Hello Android test or the activity instrumentation test case. In setup, you set up the conditions in order to carry out the test. How do you do the condition setup? You set up the activity, then you get a reference to the activity. So this dot get activity, M view, you get a reference to the text view that is part of the Hello Android examples layout on the screen. the layout uses a single text view to display that string on the screen. So you get a reference to that, and then you define this resource string called mActivity get string com.example.hello android.r.string.header. So this is the hello string that I have declared in my example there. So after I have done this setup, then you carry out this first test case saying test preconditions. What is the test preconditions test for? It is testing saying assert not null mview. What does it mean? The precondition, the first test it is carrying out is saying, in the setup, I called this mView and got a reference to this view. So the first step that I'm going to do is to test and make sure that I really have the reference to that view in the application. If that mView is set to null, that means that the text view has not been declared by the user correctly in the layout file. So obviously I don't have a reference to that, so it is going to cause a fail. So that's the first thing that I'm testing out. So this is an assertion function that I'm making use of, assert not null mview, saying that is not null, but rather it really is a reference to the text view within the layout file of Hello Android. The second test that I'm carrying out, so this is test text, and inside this test text I do this assert equals, and then I supply two string resources to this assert equals. So I'm comparing these two strings. What is this resource string? The resource string is nothing but the string directly coming from the hello string resource that has been declared in the Hello Android example. Then this particular second part is saying mView get text. This basically returns the text value of what has been printed in the text view on the screen. And so I'm comparing, saying, is the resource that is declared in the strings example the same as what has been displayed on the screen or not? So I retrieve both of them, do a comparison. If these two strings are different, then that means that there is some error in my implementation of the layout on the screen. So I can say that, look, this is not correct, right? So I can do that in practice. Now in this particular case, obviously the code has been implemented correctly within this particular example, so that's why I'm able to declare and show this information correctly. On the other hand, let me make a minor change to this main.xml file. In the main.xml file, in the text view, this is the text view that I'm checking to make sure that it is implementing correctly. So here I notice that this text field has been set to and string hello. Let me make a minor change. Let me remove that. What does this do? If I make that change, this application is simply going to display hello on the screen. That's it. This is different from what my application is supposed to have been doing in practice. After making this change, let me again run the same test case one more time on this application. So if I carry out the same test case, JUnit test case, it should report to me saying the test has failed. So it is carrying out the two tests, and then you notice that this test condition, this one has successfully completed, but the second one, it is indicating that this has failed. Okay, so and it is indicating exactly where the failure occurred. Okay, and it says JUnit framework comparison failure expected hello Android I am a string resource, but this resource actually is displayed as hello. That's the reason why the test case failed. So that's one place. that's one simple illustration of how you can make use of this instrumentation test case in order to carry out the testing of your application. So let me change this back to its original, and then again rerun the test one more time, and this time you should see that the test case runs successfully. So as you see, when I change back to the correct value, the test case runs correctly. So this way, it indicates that if there is an error in the way you coded the application, that's a good way of carrying out the test in order to ensure that your application is doing the right thing in practice. Okay? So this is the use of activity instrumentation test case. Again, going back and one more time looking at the code, hello Android test case. So as you see, this is an extension of the activity instrumentation test case 2. Why is it called test case 2? There was an initial version called test case. Now the test case 2 is an improved version of Android activity instrumentation test case. So that's why it's called activity instrumentation test case 2. Okay, nothing more special than that. In here, I have seen the use of 3 methods that are provided within the activity instrumentation test case 2 class, which I am making use of in order to carry out certain tests on my application. Okay, so getting back to activity instrumentation test case 2, what you notice is that the activity instrumentation, sorry, okay, so what is the purpose of this activity instrumentation test case 2? This is designed to do functional testing of the activities in an application using the normal system infrastructure. So it runs the activities in a normal instance of the application under test using the standard system context. So it is running under the standard context. It allows you to send, for example, mock intents to the activity under test. So for example, if an activity is going to be invoked by an intent being issued from elsewhere, you can issue a mock intent and see if this activity starts up correctly or not. If the activity does not start up correctly, then you should examine the first place to examine is the manifest file to make sure that the activity has been properly declared in the manifest file, and so on. So you can use it to test, for example, whether the activity responds to multiple types of intents and the activity expects certain data in the intent, and so on. We have seen how you can make use of intent in order to send the data to an activity from the calling side. That can be also done. The activity instrumentation test case does not allow you to supply mock contexts or mock applications. So the activity instrumentation test case 2 cannot test the activity isolated from the rest of the application. So you have to test it together with the rest of the application. But using other test case methods, you can actually carry out separate tests on an activity independent of the rest of the application. So the activity unit test case. So this is different from activity instrumentation test case 2. Activity unit test case allows you to test a single activity in isolation. As you saw, the previous one expects the activity to be tested in the context of the entire application. This you can carry out. This test case allows you to carry out testing of an activity in isolation. So how do you carry out the testing of an activity in isolation? So before you start the activity, you can, for example, inject a mock context or an application or both to the activity. You do realize that activities have a context within which they are running. So you can supply the context and see whether the activity runs correctly or not. So you can use it to run the activity tests in isolation. so that the activity will not interact with any other component within the device and carry out the tests of methods, especially of methods that do not interact with Android itself. But this approach, you cannot send mock intents to the activity, although you can call the activity by saying activity start activity intent and then look at the arguments that were received by the activity. So these kind of things can be done by using the activity unit test case. Two different methods of testing the activity. The third one, single launch activity test case. This is a convenience class that is available for you for testing an activity in an environment that doesn't change from test to test. So you can invoke setup and tear down only once, and then allows you to carry out tests on the activity. But only thing is, this particular approach, it doesn't allow you to inject any mock objects to the activity. Now, this is specifically useful for testing activities that are run in modes other than the standard modes. Okay, so this way you can test if the activity can handle multiple calls correctly or not by using this particular approach. Now, what are some of the tests that you would normally want to carry out on activity? First, input validation. Input validation, for example, if you have an activity that is controlling the UI where you have, for example, an edit text view. What is an edit text view used for? An edit text view is used for entering information back into the to supply to the activity, so that you can carry out tests on that. You can verify whether a valid keystroke sequence enables the OK button, and if you put an invalid information, it leaves the button disabled or not. You do realize that, for example, if you create an edit text button and then say that the edit text button will accept only numbers, say for example the edit text box is being used to enter the phone number and then you enter alphabets, it is not acceptable. You can test and see whether that kind of thing is being handled by the edit text button correctly. You can ensure that the activity responds to invalid input by appropriately setting error messages in the view. So for example, if you're expecting the phone number to be entered and the user enters the wrong thing like an alphabetical string, then you should be able to inform the user saying this is not acceptable, and so on, whether the activity does this correctly or not. You can carry out tests on lifecycle events. That is, you test to see each of your application's activities handle the lifecycle events correctly, all the different lifecycle events. So the lifecycle events are invoked either from the system or from the user that trigger a callback to methods like these that are implemented within your activity. So, for example, if you want to test and make sure that when you call the pause or destroy events, the activity ends up saving the state correctly or not, you can test that and so on. Even things like, for example, changes in the screen orientation cause the activity to be destroyed. So, if you want to ensure that your activity does not lose information, application state because of unexpected changes in the orientation of the device and so on, you can carry out tests like these. Third aspect, intents. Obviously, activities are invoked by sending intents, whether implicit or explicit intents. So you can test for every activity if it is correctly handling the intents. If the activity specifies an intent filter, you can test and see whether the activity properly is invoked for each of the intents listed in the intent filter. You can use this to send mock intents to the activity under test. So you can check and see whether the activity will invoke the things correctly or not. So, and runtime configuration changes. As the application is running, you can make changes to the device configuration and see whether it is handling everything correctly or not. Screen changes, screen sizes and resolutions as you change, for example. So one of the things that you should do is before you release your application, always make sure to test it on different screen sizes and densities. That's an important thing to do. Very often we neglect this aspect. Now, this is not very difficult to do in practice. The Android's AVDs that are supplied, you can configure AVDs with different screen densities. You can configure an AVD with a small screen density, large screen density, and see how your activities are laid out on different screen densities, whether the layouts are proper, whether something is overlapping the other or not, and so on. This is very important to carry out, and very often I see people neglecting this aspect when they actually carry out tests on your device. Okay? So, what I'm going to do right now is pause at this point, and then we will come back on Wednesday of next week and wrap up this chapter. And then on Friday, we will have a couple of guest lectures. All right, so let me stop at this point today and continue with your project, and then we'll see you next